Good morning. Today our new topic is operation of differential amplifier with the help of a circuit diagram. Operation of differential amplifier with the help of a circuit diagram and also block diagram of operational amplifier Okay. Next, recap of this presentation. In previous class we discussed about introduction to operational amplifiers and basic of differential amplifier and also common mode and differential mode of signals. These topics are completed in previous class. Okay. Next, objectives of this presentation. On completion of this period, you would be able to understand the operation of differential amplifier with the help of a circuit diagram. And next, block diagram of operational amplifier, op-amp IC 741 and summary. Okay, these topics one by one discussing now. First of all, the first topic is from these two topics, operation of differential amplifier with the help of a circuit diagram. Operation of differential amplifier with the help of a circuit diagram. See this circuit diagram. This is the circuit diagram of differential amplifier. Observe the circuit diagram. So the circuit diagram consists of two transistors, one power supply and common emitter and common collector configurations. Okay. So this figure shows the circuit diagram of emitter coupled differential amplifier. See this figure. This is the figure of the circuit diagram of emitter coupled differential amplifier. This figure consists of two transistors Q1 and Q2 that have, these two transistors have identical characteristics. That means ideally produces ideal characteristics. Okay. Next, they share a common positive supply VCC. VCC is the common positive supply. Okay, this supply shares both transistors. Next, common emitter resistor RA and common negative supply minus VEE. Okay, so they share a common positive supply plus VCC, a common negative supply minus VEE and also a common emitter resistor RA. Okay, it has two input signals V1 and V2. It has two input signals or V1 and V2 and output signal is nothing but V0. It has two input signals V1 and V2 and output signal is taken between the collectors of both transistors. Output signal is taken between the collectors of both transistors. Next, in the differential mode, the input signals are different from each other. In the differential mode, the input signals are different from each other. Okay. First of all, let us consider the input signals which are same in magnitude but 180 degrees out of phase. Let us consider the input signals, two input signals. So, two input signals magnitude is same but phase is 180 degrees out of phase. Okay. Assume the base of transistor Q1 is, let us assume that the base of transistor Q1 is positive going while on the base of transistor Q2 is negative going signal. Okay, negative going. So, I repeat this point again. Let us assume the base of transistor Q1 is positive going and while on the base of transistor Q2 is negative going. Okay. So, an amplified negative going signal. Develops on the collector of Q1. An amplified negative going signal develops on the collector of Q1 due to positive going signal, current through RE also increases. Due to positive going signal, current through RE also increases and hence positive going signal is developed across RE. Okay. And next, due to negative going signal on the base of transistor Q2, An amplified positive going develops on the collector of Q2. An amplified positive going develops on the collector of Q2, and a negative going signal developed across RE. A negative going signal developed across RE. So signal voltages. So the signal voltages across RE due to effect of Q1 and Q2 are equal in magnitude and 180 degrees out of phase due to matched pair of transistors. Okay, hence these two voltages cancel each other and there is voltage across the RE. Hence these two voltages cancel each other and there is voltage across RE. Therefore, next, the output voltage V0 is taken across collector of Q1 and collector of Q2. The two outputs are equal in magnitude. The two outputs are equal in magnitude but opposite in polarity. V0 is difference between these two signals. V0 is difference between these two signals. Okay. Next, these two signals. Therefore, the output voltage V0 is given by, therefore, the output voltage V0 is given by V0 is equal, so AV into VD. So AV is V0, therefore that implies V0 is equal AV of V2 minus V1. V0 is equal AV of V2 minus V1, where AV is equal gain of the amplifier, where AV is equal gain of the amplifier. Okay. Next, advantages. Advantages. So advantages is nothing but very high input resistance. Advantages is nothing but very high input resistance. Advantages of differential amplifier is nothing but advantages are, first one is very high input resistance and low output impedance. Okay, differential amplifier offers high input impedance and low output impedance. That's why, so this is one advantage. And second advantage is nothing but, so common mode rejection ratio is high. And third advantage is low drift. And fourth advantage is high stability. High stability, circuit stability is high. And next, so fifth advantage is nothing but large bandwidth. And next, fifth advantage is nothing but large bandwidth. And next, sixth advantage is nothing but, so low offset voltage and current. Low offset voltage and current. This is nothing but operation of differential amplifier with the help of circuit diagram. And next advantages also completed. Okay, so actually working of differential amplifier with detail, working of differential amplifier with detail, working of differential amplifier with detail. See this figure. This is the figure of differential amplifier. See this figure. Suppose, observe this figure. You can select any one figure. Okay, this figure, also that figure. Okay, so see this figure. Suppose the signal is applied input 1. Suppose the signal is applied at the input 1. So input 1 is nothing but Q1, that is base of transistor Q1. So suppose the signal is applied at the input 1, that is base of transistor Q1. So and what about input 2? What about input 2? That is base of transistor Q2, that is connected to ground. That is connected to ground. Okay, so that is connected to ground. Okay, so only Q1 is on, Q2 is off because it is connected to ground. Okay, the transistor Q1 so will act as in two ways, a common emitter amplifier and a common collector amplifier. Okay, so first of all we can apply the input signal. Positive going signal is applied to base of transistor Q1, so that is present at the output. That is present at the output. Output is nothing but positive going signal. When power supply is on, so then power voltage is goes to through resistor to the output. Resistor drops an voltage across the resistor drops an voltage. That voltage is applied to output. Then output voltage goes to output figure is goes to change. Okay, next. Then so this is out of phase. Then this is out of phase. So as a common emitter amplifier, the signal Q1 will appear at output 1. So collector Q1 is amplified inverted signal. I repeat once again. So here, so input is applied here. Suppose signal is applied at the input to input 1, that is base of transistor Q1. So input 2 is connected to ground. Input 2 is connected to ground. First of all, positive signal is applied to base of transistor Q1. So transistor is amplified the signal. Transistor is amplified the signal. Okay. So that signal is appears across the output. Appears across the output. Then switch on the power supply. So then voltage is goes to output through the resistor, collector resistor. So here collector is amplified inverted signal, that's why. So that is applied to output. Then output is increases, then goes to positive is goes to negative signal. And similarly as a common emitter, the input signal is Q1 will appear at output 1. Collector as amplified inverted signal as shown in figure. As a common collector amplifier, the signal appears on the emitter of Q1. So in phase with the only slightly smaller. So suppose input is applied to base of transistor Q1. So this amplified signal goes to common emitter RE and also to output. Okay, here output input 2 is grounded, therefore RE is positive going signal. Okay, since emitters of Q1 and Q2 are common, the emitter signal since emitters of Q1 and Q2 are common, the emitter signal becomes input of Q2. Similarly, so the input is the signal is applied to input 2. That means that is the base of transistor Q2. So what about Q1? It is connected to ground in second case. Then so this signal is going to output. The signal is going to output. Negative signal is going to output. Okay. Then that is applied to at the same way RE also. Here positive going, negative going signals, both are cancel each other. Next, so switch on the power supply. Then power is going to output through collector resistor. So this collector resistor is amplified inverted signal. That's why. So negative going signal is converted to positive going signal. Negative going signal is converted to positive going signal. Okay. So this is the working principle is explained in detailed in differential amplifier. Okay, differential amplifier operation is completed. And next, block diagram of operational amplifier. Block diagram of operational amplifier Op-Amp IC 741. Op-Amp IC 741. Okay, so an operational amplifier is a multi-stage amplifier with high input impedance and low output impedance. Okay, this is the basic block diagram of operational amplifier. So it is nothing but IC 741. This diagram constitutes mainly 4 blocks or 4 stages which are connected in cascaded manner. That is nothing but series connection. Okay, so what about which stages? First one is input stage. Input stage is also a differential amplifier. A second stage is nothing but intermediate stage. Intermediate stage also a differential amplifier. Third stage is nothing but level shifting stage. Third stage is nothing but level shifting stage. Level shifting stage is nothing but emitter follower, so or buffer. Emitter follower or buffer, it is a storage device. Okay, the last stage is the fourth stage is nothing but output stage. Here output stage also connected complementary push pull power amplifier. Complementary push pull power amplifier. So each and every stage, one by one stage discussed in briefly. Okay, first of all input stage. First of all input stage. So what is the purpose of input stage? Input stage consists of two inputs. Input stage consists of two inputs. Observe the input stage. Input stage also a differential amplifier. That's why it consists of two inputs, inverting input and non-inverting input. Inverting input and non-inverting input. This stage provides maximum voltage gain. This stage provides maximum voltage gain. In this stage of differential amplifiers, with a constant current source is used. With a constant current source is used in order to increase the common mode rejection ratio. Okay, this is given to second stage. Second stage also a intermediate stage. This stage also using differential amplifier. Okay, so this stage is usually another differential amplifier which is driven by the preceding output, which is driven by the preceding output. This stage is commonly used to provide additional gain. This stage is commonly used to provide additional gain. I repeat this stage also. And the second stage is nothing but intermediate stage. So this is usually another differential amplifier which is driven by the preceding output. This stage is commonly used to provide additional gain. Okay, so output of this stage is given to the input of third stage. Third stage is nothing but level shifting stage. Third stage is nothing but level shifting stage. This stage is usually an amplifier follower circuit which produces unity gain. Level shifting stage produces unity gain. It has high input resistance and also low output resistance. It has high input resistance and also low output resistance. So level shifting stage matches the output of amplifier stage and the input of output stage. This stage eliminates the chance of signal distortions. This level shifting stage eliminates the chance of signal distortions. Okay, so output of level shifting stage is given to the output stage, that is the final stage. The level shifter adjusts the DC voltage so that output will vary about a zero reference level, thus preventing any undesired DC current, the load, and also increasing the permissible output voltage swing. I repeat again, level shifting stage. So this stage is usually an amplifier follower circuit which produces unity gain. It has high input resistance and also low output resistance. It matches the output of amplifier stage and the input of output stage. This stage eliminates the chance of signal distortions. This stage eliminates the chance of signal distortions. The level shifter adjusts the DC voltage. The level shifter adjusts the DC voltage so that output will vary about a zero reference level, thus preventing any undesired DC current, the load, and also increasing the permissible output voltage swing. Okay, so output of level shifting stage is given to the input of output stage. Finally, the output stage, the last stage, is nothing but an operational amplifier. So it is usually a complementary push-pull amplifier. Finally, the output stage is nothing but an operational amplifier. It is usually a complementary push-pull power amplifier. This stage uses the output voltage swing and the current delivering capabilities. This stage increases the output voltage swing and the current delivering capabilities. It also essential for providing low output impedances. It also essential for providing low output impedances. Okay, so this is nothing but the block diagram of operational amplifier op-amp IC 741. So this is nothing but operational amplifier. This is common positive power supply and common negative power supply, and two inputs, different inputs are applied to at the first stage. Okay, so block diagram of an operational amplifier. Observe this. So with output with 0 DC level, figure A, observe this waveforms. Figure A waveform is output with 0 DC level. There is no distortion in this figure A. Okay, so next, what about figure B? It is distorted output due to additional DC level. It is distorted output due to additional DC level. Okay, this is completed. Okay, today topics are completed. And next, summary of this presentation, we have seen operation of differential amplifier with the help of a circuit diagram and block diagram of operational amplifier op-amp IC 741. So these topics are completed. And next, frequently asked questions may be asked. The first question is, explain the working of differential amplifier with circuit diagram. Explain the working of differential amplifier with circuit diagram. And second question may also be asked as, explain the block diagram of operational amplifier. Explain the block diagram of operational amplifier. Okay, so these two topics are completed. These two topics are very important topics. Prepare well. Okay, thank you.